semester project. These last three projects are either teaching the project.
And we're senior design one, so we have more to build on. All right. Good afternoon. We are Team Autonomous Transportation for Autonomous Vehicles. My name is Joshua Price. My major contribution was the autonomous transportation algorithm. Shayla's main contribution was the robotics. Jesus' contribution was the wireless communication. And Joshua K's contribution was power distribution. Our project is basically designed to design a safe, affordable, autonomous transportation system. There are other companies that are creating something similar to this in anticipation of a future where all vehicles are autonomous vehicles. Such companies as Google are working on a Google car. Ours is different in the sense that we are shifting the burden of the cost away from the automobile consumer, where Google has put the burden of the cost onto the consumer. The sensors alone on the Google car are $150,000 currently. To create our system, our cars are radio controlled and they're identified with RFID. Our roads are divided into autonomous subsystems. Subsystems are intelligent in the sense that they control the flow of traffic within the subsystem as well as communicate with neighboring subsystems, such as timing and spacing issues. And then they can also receive information from the cloud for traffic rerouting purposes, such as accidents or emergency vehicles. They also send information to the cloud for cloud storage and later analysis. Our system is basically sensor-driven. The sensors detect vehicles, they identify vehicles, and then they control vehicles within their subsystem and pass them on to another subsystem. Our algorithm, for the subsystem, the algorithm will be slightly different. The algorithm is basically to maximize throughput to the safest limits possible. Today we will be presenting a four-way intersection subsystem, a fairly simple subsystem, but we will also have a computer simulation of a more sophisticated intersection subsystem as well. In Senior Design 2, we will be adding path awareness to our vehicles so that they can follow a certain path as well as to respond to particular changes in the environment, such as accidents. We can simulate accidents or roadway closures, and the vehicles can reroute themselves, and then the intersection will still control the throughput through the intersection. And that is our project. Questions?
Any questions?
Sir.
What's your vision of the objective here? I mean,
The vision is that the sensors are placed into the roadway, and the sensors control the vehicles. The vehicles are basically just radio controlled. They have very few sensors in them to keep the cost cheap, and we can use the current vehicles that we have now. We don't have to redesign vehicles and add extra sensors in them. The sensors in the road actually control the flow of traffic with two-way communication with the vehicles, controlling speed, controlling turning, so that the vehicle will know only its destination, and then the communication with the road will shuttle the vehicles running.
we go with the
I can get a little work.
Go ahead, no, go ahead.
So somewhere, somebody's keeping track of every car all the time?
No, not necessarily. There will be the ability, through the ability to send, for the subsystem to send information to the cloud, which could include the identification of the vehicle. So yeah, you could have the potential to know where every vehicle is at any given time, in case that you needed to, stop a fleeing vehicle. The police could override the subsystem and shut the car down. In certain cases like that, or if a car's gone rogue, you would have the ability to shut the car down as well.
I was just even thinking of much simpler than that. You said, okay, you start out, you said, this is where I want to go, and it figures out where to go. I mean, keeping track of where I am all the time and all the other impediments along the way to get there.
It's not necessarily keeping track. So the subsystem knows if it's a straight subsystem, a straight road, well, it doesn't care where you're going. It's just trying to control your speed. But in situations of an intersection, if you need to turn, the vehicle would know that, these coordinates have to be routed through this way. These coordinates can go straight, and such. So that each autonomous subsystem would have different requirements and would use different things with the coordinates of the vehicle's destination.
Is there an integration path with GPS?
There's not currently, no. So our vehicles right now are just complete remote control cars. But yes, eventually we'd be able to enter in a destination that would be, take a GPS route.
So what kind of work have you done? This is mostly software.
Mostly it's been software algorithms. We have our two vehicles here. These are our remote control vehicles. And we've created a simple intersection. Right now we just have a south and an east lane. And we have photoresistors set up at the end of wires so that whenever the vehicles trip the photoresistors, it'll calculate the speed for the other car at the time that it crosses its photoresistor so that it'll avoid collisions within the subsystem. So that's where we are currently. And then we also have a computer simulation that's a little more complex than our physical system.
Thank you.
What's the discipline there?
Computer engineering.